Hello everyone, I am your friend Shadab Imam and currently we are dealing with the topic of game theory. In today's lecture, we are going to see another important problem with two-person zero-sum game with saddle point. So please watch this video till the end, and if you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So let us move towards the problem. So the first problem says that solve the game matrix given below, which represents the payoff matrix of player A. So this is the payoff matrix for player A. Find the optimal strategy, find the value of game, and is the game fair? So first of all, in any problem, we need to identify that if there is a saddle point or not. So in order to identify, first we will calculate the row minimum value. So we will calculate row min, and in this we will select the minimum value in each row. So in first row, minimum value is -3. This is -3. This is second row, minimum value is 0. In third row, minimum value is -4. Now among these value, we will select the maximum value. So we can see that among these values, 0 is the maximum value. So we can say that this is our maximin value. This is maximin value. Now similarly, we will calculate another term which is called column max. In this, we will select the maximum value in each column. So in column 1, we can see the maximum value is 5. This will be 5. In column 2, the maximum value is 0. In column 3, the maximum value is 6. Now among these values, we will select the minimum value. So we can see here the minimum value is 0, and this value is known as minimax value. Minimax value. And now in the introductory lecture, we have seen that the condition for a saddle point is that the value of maximin should be equal to the value of minimax. So for saddle point, the value of maximin has to be equal to the value of minimax. So we can see here that maximin is 0 and minimax value is also 0. So we can see here, we can say that in this particular game there exists a saddle point, and the location of saddle point is the intersection of this row and this column, which is this particular element. So here, according to this two element, second row and second column element, is the location of saddle point, and this indicates that player A will continuously play strategy 2 100% of time. Similarly, player B will continuously play strategy 2 100% of time, and they will not play any other strategy. So from this we can say the optimal strategy for player A and B can be identified. So the optimal strategy for player A can be given as 0 1 0. This shows that player A will play strategy 1 0% of time, strategy 2 100% of time, and strategy 3 0% of time. Similarly, we can also show the optimal strategy for player B. So optimal strategy for player B, and this can also be represented as 0 1 0. And this also shows that player B will play strategy 1 0% of time, strategy 2 100% of time, and strategy 3 0% of time. So the first part is complete. Now the value of game. Whenever we have a saddle point, then the element at the location of saddle point, we have seen that the location of saddle point is 2, that is second row and second column. So the element at this place will be the value of game, or we can say the value of maximin is equals to value of minimax is equal to the value of game. So according to this, the value of game for player A and B both is 0. So here we can say the value of game is 0. And now moving on to the third part, it says that is the game fair. And in the introductory lecture also we have seen that the condition for a game to be fair is when the maximum value is equal to the minimax value, which is equal to 0. So if this particular condition satisfied, then only we can say that a game is fair. So from this particular problem or game, we can see that the maximum value is equal to the minimax value, which is equal to 0. So this condition is satisfied. So from this we can say that this game is fair. So I am writing it here, this game is fair. So I hope you understand this. Now let us move on to the second problem, and the second problem says that solve the game whose payoff matrix for player A is given. So here also payoff matrix for player A is given and we need to solve. That means we need to identify the strategies for player A and B. So similarly, just as we have done in the previous problem, we will calculate the value of row min here. So the row min is -2 because there are two places where equal values are there. Similarly, in the second row it is -6 and the third row it is -8. And among these value we will select the maximum value. So among these the maximum is -2. So this value will become the maxi-min value. Maxi-min value. And now we will calculate another term which is called column max. In this we will select the maximum value in the column. So in column 1 we can see that the maximum value is -2. So here this is -2. In the second column the maximum value is 20. So this will be 20. And the third column we can see the maximum value is -2. So here again -2. So among these value we will select the minimum value. So in this particular game we can see here that there are two values which are equal. So both can be considered as minimum value, this value and this particular value, and this both values are minimax values. This is also a minimax value, this is also a minimax value. And now as a result what happened is, in a game we have a saddle point where the value of minimax is equal to the value of maximin. So we can see here that the maximin value is -2 and the minimax value is also -2, but in this particular game we have two minimax values, that means two values which are equal, -2 and -2. What this suggests is that we have a multiple saddle point here. Now what multiple saddle point suggests, that multiple saddle point exists, it is very similar to what we call multiple solution. So one solution for each saddle point. So let us consider one by one. So if we consider these two, maximin and minimax value, then their intersection element will be this, that is for this row and this particular column. So the intersection point is this, and this is where saddle point exists. Now if we consider the maximum value this and the minimax value this, we can see that we will have the intersection cell as this, and here also we had a saddle point. So there are two possible solutions for this. One is when we consider a saddle point at this cell, and another is when we consider a saddle point in this cell. So what this suggests that this game has two saddle points, at 1 1 and at location 1 3 and at location 1 3. So there are two saddle points at 1 1 and at 1 3. Now how can we show the optimal strategies for player A and B? So the optimal strategy for player A is when player A will play strategy 1 100% of time, because it will both the saddle points are coming in this row, and this suggests that in any manner player A has to play strategy 1 for 100% of time, or we can show this as 1 0 0. That means player A will play strategy 1 100% of time, strategy 2 0% of time, strategy 3 0% of time. Similarly, we can have optimal strategy for player B, and this can be represented by 1 0 0 or 0 0 1. Now what this suggests as that we can have one saddle point at a time, because if we consider the strategies for player B, the saddle point existed in strategy 1 at this location and in strategy 3 at this location. So either player B can play strategy 1 100% of time, or it can play strategy 3 100% of time. So there can be two possibilities, or we can say two optimal strategies for player B. Either it can play strategy 1 100% of time and strategy 2 and 3 0% of time, or it can play strategy 1 and 2 0% of time and strategy 3 100% of time. So this shows that player B has two optimal strategies, where player A has a single optimal strategy. So this is the case where we have multiple saddle point, and which is equivalent to multiple solution in a problem. So I hope this is clear to you. If you like this lecture, please share the lecture. Have a nice day. Thank you.